Hi everybody, I just wanted to share with you an assignment for today. This is Mrs. T. Hope everybody's doing well. I miss everybody and I really hope that we can get back to school very soon. But what I'd like for you to do, and there will be an accompanying assignment in Google Classroom, what I'd like for you to do is look at the pictures provided of the voltaic cells and note as many similarities as you can. I will introduce the pictures in this video, but you need to go to Google Classroom to submit your work. So in a voltaic cell will use a redox reaction to actually provide electricity. So they convert chemical energy to electrical energy via a spontaneous redox reaction. And now these are all different diagrams from past Regents exams of voltaic cells. And what I do want to point out is that in a voltaic cell acts as a battery, and it is a battery. So everybody right now who is working on a tablet, laptop, Chromebook, phone, iPad, whatever you're working on, the battery inside your device is a voltaic cell. And there is a redox reaction happening that happens on its own without help, so we call it spontaneous, and that converts the chemical energy into electrical energy. Usually, a voltaic cell will have a voltmeter that measures the voltage, measures the amount of electricity being given off. But we can also light a light bulb or work a device, get a device going with electricity because of the fact that this voltaic cell is providing that electricity. So just some general things for our voltaic cells, there always has to be a wire, okay? The wire is where the electrons flow. And the electrons are always going to flow from the electrode that is the anode to the cathode. And we know that the anode is where oxidation happens, which is where electrons are lost, and the cathode is where electrons are gained, where reduction happens. So electrons always flow from anode to cathode, from an ox to a big red cat. Another thing or another item that has to be present in a voltaic cell would be a salt bridge or a means for the ions to get from one place to another. So the ions travel in the salt bridge, or they are exchanged through the porous parts. Because as redox happens, we know that we are having a buildup of ions on each side, some positive, some negative. So in order to keep these solutions electrically neutral, the ions, positive and negative ions, will flow through the salt bridge. Again, electrons go through the wire from whichever one is the anode, which is whoever's being oxidized, to whichever one is the cathode, to whichever is being reduced. So in this case, iron is the anode and copper is the cathode because iron's oxidation number is going up from 0 to +2. Copper's oxidation number is going down from +2 to 0. That means that negative electrons are being gained by the copper +2 and lost by the iron 0. Electrons always flow through the wire from anode to cathode, and ions always flow through the salt bridge. We also always need to have electrolyte solutions in each compartment with the electrodes. So each compartment has to have a solution with ions. In this case, the setup is much different. Okay, this one is much different because we're using gases. We don't typically see this, but this did show up on the Regents a couple of years ago. So again, what I'd like for you to do is take a look at this diagram on Classroom, and please be sure to take a look at that and make sure that you are uploading your picture where you have either typed in or drawn the similarities that you see between the different voltaic cells. As always, please reach out via Remind or email if you have any questions. And on Fridays between 11:15 and 12, I do offer either recorded or live streaming extra help depending on what the case is each week. So please reach out if you have any questions. I hope everybody is home and safe and healthy with their families. Miss you guys. Bye.